So we have been working on my home network and with a router, a gateway router here, and this whole network, it contains my MacBook and iPad and also my TV. And this is managed by this gateway router, so it is a local area network. And we have the DHCP. So by DHCP, a host like here, my Kali Linux, can obtain IP addresses, which contains the IP address for Kali Linux itself. It contains the subnet masking, and it contains the IP address of the gateway router. It also contains the IP address of the DNS server. And we learned that in this local area network, all the traffic is managed by the layer 2 switch. And it means all the traffic, it is managed there. We can replace this gateway router with a switch, that everything works fine with this local area network, except we cannot talk to the external network. And all the traffic is based on the MAC addresses in this local area network. So the switch will maintain the mapping of its interface and the corresponding MAC addresses of some device. And then we have learned this ARP. This by ARP, the devices can talk to each other at the layer 2 and exchange their MAC addresses. And basically, when these two protocol is what is so-called plug and play protocol, it means the end user will not really know what's happening behind this plug and play, this scenario. So for the end user, they just connect to their device to the local area network, either widely or wirelessly, and then they get the internet like magic. And in fact, when the device get these IP addresses, it also needs this ARP, the address resolution protocol, to ask for MAC addresses of other devices in this network, especially the router. And then it will store this MAC address of the router in its cache, local cache. We have demonstrated like this local cache can be poisoned, can be changed by for certain purpose. Like we have demonstrated we can mess it up by changing some entry, and then we cannot find the specific device in this local area network. We also mentioned the ARP spoofing for the inside this network, not just the local device. And this process is the attacker, like here, the Kali Linux machine as an attacker. If it wants to mess up with like iPad or MacBook here, then it can continuously send ARP reply telling this device, okay, the router's IP address is at my MAC address here. So it will continue to send this ARP reply, and the local ARP cache in MacBook will not authenticate the original device. It will just update its ARP cache, and then it causes problem. So you see the design of ARP itself, it does not contain the authentication in the first place, then it causes a problem. And here we have like me see when it's updated. We have fake. Okay, I need to recapture again. It seems dead. Okay, now it's back. So this ARP spoofing, in fact, it's fake MAC address associated with a valid IP address in the local area network. Then it causes a problem. And in this case, so if Kali Linux only send out ARP reply to forge the route IP address, route as a MAC address to MacBook, then it calls the deniable service, because if MacBook wants to talk to the router here, then it will send its traffic to Kali Linux. That's a problem. And if this Kali Linux is configured with the IP forwarding functionality enabled, then this Kali Linux can also send the ARP reply to router, forge MacBook's IP address, forge MacBook's MAC address corresponding to its IP address. Then the router will also send the traffic which was intended for MacBook, but it in fact sent to Kali Linux, and Kali Linux will forward this to MacBook. So it's if it sends out ARP reply, it also sends out ARP reply to router here. Then it implement this what is called man in the middle man-in-the-middle attack. So in this way, the attack machine here can intercept all the traffic between the router and the MacBook. And for MacBook, mostly like if this machine visits some website, nowadays most of the machine, the website maintains the HTTPS. So the router here, the attack here, although it can intercept all this traffic, but it cannot read the content because the traffic between MacBook and router here is encrypted. All the MacBook traffic between MacBook to the external network, maybe Google or like Facebook, another web server here, the traffic itself is encrypted. So the attacker's machine here cannot really read the content of this this information, this traffic. So that's the kind of the limitation of this man-in-the-middle attack. And we have used this ARP spoofing, this command to here. So today I use a MacBook as a victim machine. I use victim machine here, and then we have this command like use ARP spoofing, and today we can try another more advanced tool, which is Ettercap. And this tool, it's designed for man-in-the-middle attack. So it can capture the ARP request ARP message between the two machines, and it can also capture the port, capture DHCP, this message. It has quite a lot functionality. So let's see how it works with Ettercap, this command. It is installed in Kali Linux. So if we look at Ettercap, it's a menu, and it's mentioned, you see, Ettercap was born as a sniffer for switch name, and then it has been developed, further expanded, and then it becomes a powerful and flexible tool for man-in-the-middle attacks. And there are this command line interface. It also has the graphical interface. So you can, if you are running Windows machine, that graphical interface provides more functionality, more user-friendly interface. But for Mac OS and for Linux, the interface is not so friendly to the user. So I prefer to use the command line. And the usage of this Ettercap you see here. So since it's in the middle, so then it needs to specify the target, 2 targets, the target 1, target 2. Mostly these targets are the, one is the victim machine, the other one is the router, gateway router. In this way, then this attack machine can capture all the traffic it's interested in. And it has several functionality. Okay. So when we use it, we need to specify this, what are the traffic Ettercap wants to capture. Since it has several functionality, several features, then we need to specify like ARP and also like DHCP, you just see, and the port, and also another is NDP. So these are 4 protocol traffic. And let's see how it works. So first of all, I need to know what are the IP addresses, what are the active IP addresses in my local area network, and what are the IP addresses for the targets. So I again use ARP scan -L stands for the local area network. It captures this information, and this is my Mac hosting the Kali Linux, and this is a router. These are the 2 targets I'm interested in. And how it works is I use Ettercap and -li to specify the interface. For Kali Linux, it's not necessary to have this, but if you are using Windows or if you are using Mac OS, then you need to specify this interface because they contain several network interfaces there. Then I need to specify what are the modes of the man-in-the-middle attack. So it's for ARP. And before it normally has extra function on this to specify. One is I want to see some text message, text output in this process, which tells me what's going on with this software. And mostly when I use this Ettercap as an attacker, then I don't want the others lose this. So I want to keep this attack as silent as possible. So I don't want the others to be annoyed or to be mindful of my capture behavior. So I use it stands for quiet. So it can be lowercase q, it's fine. And then I need to specify my targets. One is 10.0.0.138. Another is 10.0.0.66. And in Ettercap, it's rather advanced. So it's not just working for IP version 4, it also works for IP version 6. And it also gives the option like to make the target not just a one IP, it could be a group of IPs. And also it can contain the MAC address information of this IP. So it's quite advanced, and it has this format MAC, that IP version 4, IP version 6, and also the port. This is the format of its target. And in this case, we are only working on IP version 4, and the others, we keep it empty. So then we have the target in this format. So leave the first field empty, and then we fill in the second field for IP version 4, and we leave the third field, IP version 6, empty, and we also leave the last field, port, empty. And we have the same format for the victim machine. Then in this case, you see it's from here, you see it gets some information. Up pointing the victim is this one, and then the group 2 is any. Here there's one usage that in this case we want to capture the traffic between the router here and this victim machine here. So we also need to make it more specific to the command. At the moment, this command is not complete, so it ignores the first part. So let's first clear the screen. In fact, here we need to specify this remote. This parameter is optional, and by doing this, then it means this command will capture the traffic between this router and this machine. Let's see it. Now you see here, now it's group 1 is the router, group 2 is this machine. And let me see here. Let's see whether I have captured some traffic. You see here, it's the traffic from my Mac to this IP address, and it uses the protocol UDP as a translator protocol here. Let's see whether we have captured some other information. So it captures only This one, let me see here. Suppose I type in uib.no. No, this I try google.com. Let's see. Stop and let's see whether we have captured some traffic between my Mac and google.com. 443. I will introduce this very soon. Okay, here we have several of these TCP traffic. So I guess like in this area, the traffic was captured. We have captured more traffic here. So this is how the Ettercap works for the ARP spoofing, or for the purpose of man-in-the-middle attack. I think we can have a 10 minutes break, then we can continue. Just to keep not keep you looking at the screen all the time. Okay, we start at 10:55. See you later.